Hi guys, welcome to another video of Physics 2. This is the problem number 2 about the Newton's second law and the motion in one dimension. So this is the problem. It says a 50 kilograms body moves at 22 meters per second when a 45 newtons force acts on it for 10 seconds. Find the distance that the body travels at constant acceleration. Okay, so I'm going to make the drawing here. I'm just gonna change the color. Okay, it says that I have a 50 kilogram body, so and moves. Okay, so they don't give me the direction, so I'm going to assume the direction is to the right. So that means that the direction will be positive, because you need to remember the reference system. Everything that goes to the left is negative and everything that goes to the right is positive. So for example, I'm going to assume that this is a body. Let's say that it's a, I don't know, it's a box, okay? And well, it's moving, so I'm going to assume that it has wheels, okay? So it's moving to the right. And for example, it has constant velocity, 22 meters per second. And at some point, there is a force that acts on that body. And if you see, that force is positive. So I'm going to assume that that force goes in the same direction, okay? So the box or this body will increase the velocity because there is a force that acts on it. So that means that now I'm going to have acceleration. And just remember that the acceleration is the change in velocity, okay? So from here to here, there are 10 seconds. That's the time that the force acts on the body. And after those 10 seconds, the force disappears, okay? So it says, well, let's write the data here. So here I'm gonna have initial position. Most of the times the initial position is 0 meters, unless the problem says something different. Okay, this will be, to me, this will be the initial velocity. So the initial velocity, I'm going to assume that this is the initial velocity, 22 meters per second. Okay, and this point over here is when the force is not acting in the body anymore. So this is the final position. This is the final velocity. I mean, I don't know those values. I know that the force is 45 newtons. Okay, so I need to find the distance that the body travel at constant acceleration. So that means the distance that the body travel with this force. So this is the question over here. Okay, now I'm going to solve this problem in another window. I'm gonna do it over here. Okay, so I'm gonna write the data again, data, and I'm gonna write that initial position is 0 meters. Remember that most of the times is 0 unless the problem says something different. The initial velocity is the initial velocity that the body has, 22 meters per second. Okay, the mass of the body is 15 kilograms. There is a force that acts on this body that is 45 newtons. 45 newtons, okay? The time is 10 seconds. And I need to find the distance that the body travel with constant acceleration. So I need to find the final position, okay? So I'm gonna begin by writing this formula over here, the Newton's second law, that says force equals the mass times the acceleration. Just remember that the force is a vector, okay, and the acceleration is a vector too. The mass is a scalar quantity, And just remember that the force has the same direction of the acceleration. So if the force goes to the right, that means that the acceleration goes to the right as well. Okay, so for example, I'm going to write another equation. Acceleration equals final velocity minus initial velocity over time. And finally, this formula, final position equals initial position plus initial velocity that multiplies the time plus the acceleration times square over 2. Okay, so I need this distance over here, this position or the displacement. Okay, and I know that the problem says distance, but many books they treat distance and displacement as the same. But of course, just remember, and I'm telling you that distance in this case will be the position, that it will be the displacement. In this case, it will be a vector. So just remember, I have initial position, initial velocity, I have it, time, I have it, acceleration, I don't have it, and time, of course, I have. Okay, so if I want to use this equation, well, I can cancel the initial position because I'm pretty sure it's 0. So I'm going to write it again. Final position equals initial velocity that multiplies the time plus the acceleration times square over 2. Now, from this equation, the only variable that I don't know is the acceleration. Okay, but if I want to find the acceleration, I can go to this equation over here and I can say acceleration, I don't have it. I don't have final velocity either. I have initial velocity and I have time. So if you remember, I cannot use this equation because I got 2 cross marks. That's something I explained in the previous videos. This one has 2 cross marks too, so I cannot use it. So if I go to the first equation that I just wrote, this one over here, the Newton's second law, I can say that, okay, do I have the force? Yeah, 45 newtons. There is a force of 45 newtons that acts on the body. Do I have the mass of the body? Yeah, it is 15 kilograms, okay? And the acceleration? No, I don't know the acceleration, but I can find it. So acceleration equals the value of the force over the mass, okay? Oops, sorry, the mass. So in this case, it will be 45 newtons over 15 kilograms. So acceleration in this case, if you want to get a calculator, so it will be 45 over 15. And that is the value of the acceleration. If you want to know the units of the acceleration, just remember that newtons are kilograms times meters per second square. Okay, so in this case I got newtons. I'm going to write it. Okay, newtons, these are newtons and they are divided by kilograms. So if I have this, I'm going to cancel kilograms, and the units that I got left are meters per second square. So I'm going to write that the acceleration is meters per second square. Now with the value of the acceleration, I can find the final position. And I'm going to write it. Final position equals the value of the initial velocity. How much is the initial velocity? 22 meters per second. 22 meters per second, and multiplies the time, that is 10 seconds, plus the value of the acceleration, 3 meters per second square, times the time, 10 seconds raised to the square over 2. I can do this operation easily in my calculator. So it's going to be 22 times 10. So I'm going to do this, 22 times 10. And then plus, and this is a fraction, 3 times 10 raised to the square over 2. Okay, and that is the answer. But what are the units? Just remember, seconds cancel with seconds, and second square are going to be canceled with second square. Okay, so the answer to this problem will be final position equals 370 meters. Okay, that is the distance or the displacement. If we say that displacement, okay, the displacement is positive because this is the magnitude and the sign of the number is the direction. In this case, the direction is positive, so that's why the motion goes to the right. Okay, so this was the second problem of Newton's second law and combining with the motion in one dimension. I hope I made myself clear with this problem, and I hope I see you in the next video. See you guys.